Alright, welcome everyone to my video. Today I'm going to give you a very quick review on MOSFET siezing. On MOSFET siezing, please, you just have to follow me carefully. What are MOSFETs? That is what we need to know first. Let me give a very brief introduction and then we just move on quickly. The full meaning of MOSFET is the metal oxide semiconductor field effect transistor, most commonly fabricated by the controlled oxidation of silicon. It has an insulated gate, the gate of which determines the conductivity of the device. Please mark this word. The voltage at which determines the conductivity of the device. This ability to change the conductivity with the amount of applied voltage can be used for amplifying or switching electronic signal. That is the main major function of a MOSFET. So please put that in mind. It's mainly used for switching electronic signals. A metal insulated semiconductor field effect transistor is a term almost synonymous with MOSFET. Another synonymous is IGFET for insulated gate field effect transistors. Now that is the IGBT. I will also introduce you to that. Now these are the few characteristics I will be sharing with you here. Mainly they are designed to switch high voltage using analog inputs, and MOSFET have capability of switching up to 400 kilohertz. That is for MOSFET. Then 5 volts switches the MOSFET halfway and 10 volts switches the MOSFET fully. Now I'm going to explain that too later, so these are just basic introductions on this. Now we have the single MOSFET, which is the normal channel N and P channel MOSFET with 3 pin, and we have the IGBTs. The IGBTs have to have like 7 pin each dual IGBT. I'm not talking of single block, I'm talking of dual block. It has 2 MOSFET inside, 2 N-channel MOSFET inside. I'm going to show you the diagram too in a very short time. So quickly I'm going to go you through the calculation and sizing. Okay, let's see, for example, we are going to be using a 3205 MOSFET, a very popular MOSFET. But first let me just introduce you to this formula, then we go quickly. The formula here is V is equals to voltage. That is the maximum drain to source voltage. That is from the middle pin of the MOSFET to the first pin from your right. That is the source. So that is how to determine the wattage of each MOSFET. Now if you check, this is the formula below. V times I. V is the voltage, maximum drain to source voltage, and I is the maximum drain to source current, which will give us the total power which that MOSFET can carry at maximum. Please follow me carefully. That is at maximum. Now quickly I want us to take a review on this. Sorry, I use a very wrong orientation. You have to follow me carefully. Now I said we are going to use IR3205 MOSFET. Now the type of transistor is MOSFET and type of control channel is N-channel. That shows when a signal is given to the gate, it clicks, it conducts. When a signal goes off, it closes. It opens. When a signal is given, it closes. Then when a signal is taken away, it opens. Now the maximum drain to source voltage, which I explained to you earlier, is what we need to calculate. The maximum gate to source voltage, that one is maximum to drain. That is the maximum current that the MOSFET can switch. Maximum drain to source voltage is the maximum voltage the MOSFET can switch. Yes. Then the maximum gate source voltage is the maximum voltage the gate can receive to switch. Please follow me carefully. The maximum gate source voltage is the maximum voltage the gate need. So at times when you see your MOSFET, you need to make sure that the voltage switching your gate MOSFET must be between 5 to 15 voltage. That is for this MOSFET particularly, should be from 5 to 15. If you want to switch it halfway, halfway. For example, your supply voltage that will be switching is 20 volt, and you want to switch let's say 10 volt. You want to switch 10 volt, for example. You want to switch between 10 volts. You just power your gate, let the analog signal be up to 5 volt. You can use a MOSFET driver insert, but you can use the analog input for the gate should be around 5 volt. It will open the MOSFET halfway, not fully. Then if you want to open the gate fully, then you can supply from 10 to 15 volt. It will open the MOSFET fully. So maximum gate threshold voltage is 4 volt. That shows the minimum. The threshold voltage is 4 volt. The maximum drain current is 110 amp. So if you calculate, if you multiply 55 times 110, it will give you the total wattage this MOSFET can conduct at maximum peak, at maximum, and it will be very wrong for you to conduct it at maximum. So let's say, for example, I want to design a 1 kV inverter using this MOSFET, particularly a 1 kV. And now let's say, and a 1 kV is 12 volt. 1 kV is 12 volt by default. So now we can say 12, since we are going to be using 12 volt, you can say 12 times 100. Let's not even say 110. 12 times 100, for example. Now 12 times 100 would give us 1200. That shows one MOSFET can design a 1 kV inverter. Please follow me carefully. That shows one MOSFET can design a 1 kV inverter. But in order for that MOSFET to hit at maximum, you can make it like 2 for 1 kV, and it will work. So far as it is properly mounted on a heatsink, it will work very well. So this is, if you want to design 2 kV, if it is 12 volt, for example, you want to use it again for 12 volt, then you can make the MOSFET 4 on each side. You can make it 4 on each side. Then if you want to make like 3 kV, then it's advisable now you go for 24 volt system. So mind you, this voltage, as you can see, maximum drain to source voltage is 55 volt. You can't use this MOSFET for 48 volt system, because the battery full for 48 volt system is 56 volt. So you need to look for another different MOSFET. So that is the simplest way to calculate your MOSFET sizing. So let's say you want to design a 10 kV using this MOSFET. That shows on each gate you need like since for 1 kV, let's say, for example, you are using a 12 volt system and you want to design 5 kV, you will need like 10 of this MOSFET on each gate. That is for example, but it's not advisable you design 12 volt with 5 kV. 5 kV. It's advisable like 5 kV you can use 48 volt recommended, but you can still design with 24 volt, and this MOSFET will work for 24 volt. But if you are using this one to design 5 kV, this kind of MOSFET, then you need on each side, you need like 6. That is for 24 volt, like 6, and the fan has to be standby on so that the temperature will not be very high, and it needs to be a very high capacity fan so that it can blow the heatsink as fast as possible, because the MOSFET will heat. So recommended MOSFET for like 48 volt system is IRF B4110. That is a recommended MOSFET, or you use IRFB 3077. Those are most recommended and most widely used MOSFET for 48 volt system. So that is a simple calculation for calculating your MOSFET. So as you calculate and see the maximum wattage the MOSFET can carry, you can slash the wattage into 2 and then multiply it. Okay, let's say for example, this MOSFET, as I've said, you can use 2 for 1 kV each side. So let's say for example, I've slashed, if you can see, I've slashed the power, almost divide by 2. So you can just say, okay, if the MOSFET is 1 on each side, then you can make it 2 2. If it is 2 on each side, you can make it 4 4, so that there will be less heating on the MOSFET. So this is a typical image of the IGBT block. These MOSFET are mostly recommended for high voltage inverters. Maybe you don't want to do much of soldering, much of assembling, you can use this IGBT. Those, they are very expensive, but they last very long and they take time before they get damaged. So most of the times, if you see these IGBTs bridging, it is just on a sleep mode. Once you disconnect it, keep it for like 24-48 hours, it will recover again and you can continue using it. That is the advantage of this particular MOSFET. And if, for example, you are using like 6 MOSFET for 7 kVA on each side, you can use this IGBT 2 for 7 kVA for the 4 side, because as you can see very carefully, each side you can see dual MOSFET on it. So it is mounted on a heat sink and the fan has to be standby, so that you can, if you are using this kind of MOSFET or IGBT to design an inverter, the fan has to be standby. But they are very reliable and they are very strong. Please make sure you keep your comments below. Thank you. Please like, share and subscribe on this video. Thank you. See you on the next video.